Hello, and thank you for your interest in the Active Pro Firmware Logic Analyzer. Today we're going to show you how to set up a firmware project from scratch in order to debug your firmware, sending debug output from your firmware to the Active Pro. In order to do this, it's very simple. You need to go to our website. On the support page, there is a user's manual, and in the user's manual, there is an Active Pro Debugger port section. In this section, it describes how it actually works, but we are going to go down to the bottom and get the file called active.c. We're going to copy the whole active.c file, which includes all of this stuff down to here. You're going to go to your IDE of choice. In this case, we're using a PSOC 5 processor. We need to add a file called active.c. So we're going to go, in this case, to a source file. We're going to create a new item. This is a C file. It's called active.c. Okay, we're going to create that, and we're going to just paste in what was on the website. Okay, then we're going to go to the header files, and we're going to make an active.h. This is a header file for defining the calls that we're going to use to output debug data. And this is active.h. Okay, again, go back to the website. We're going to get the active.h contents. This is literally just a header of the definitions of the file, subroutines that we're going to use, paste that in there, and we'll go through those in a second. The microprocessor will send out the debug data out a couple of different types of ports out your processor. Today we're going to just show you the digital I/O pin mode. We're going to use 2 I/O pins in this processor. The way you define those is you drag the output pin to a schematic. We're going to do a little modification. We're going to call this one active clock. This one's going to be called active data. We're going to set up which pins those are attached to. We're going to use 12.0, and we're also going to use 12.1. Again, this is PSOC specific. If your microprocessor is different, you need to set it up to use whichever pins you like. So we are now going to go into the active.c file that we created, and we're going to make a couple changes. You're going to have to do this as well. The change number 1 is we need to include whatever header files this particular IDE or this particular processor needs in order to either toggle those pins or send a byte to the SPI or send a byte to the UART, whichever one you're going to be using. In the case of the PSOC, we just need one. It's called project.h. Okay. The second change we need to do is do whatever we need in the active init routine to set up that particular processor feature we're going to use. So we're using 2 I/O pins here. So I'm going to get rid of this in the example. This particular line right here is the line that we need to basically turn on the active clock pin that we created and the active data pin that we created and drive those strong. This routine is the change number 3. This is the routine that actually sends out data out the interface of your choice. The default in the website is SPI, but we're not going to use SPI. We are going to bit bang it. And the way we do that is with this 2-wire code right here. So we're going to uncomment this. And you can do that as well if it fits your purpose. And literally all this does is it calls the PSOC write to the digital I/O a level. We're going to build this project just to make sure that it compiles without errors. Okay, as you can see, it compiled, worked fine. We are now able to use those routines. So what we're going to do, we're going to go into the main code. This is part of PSOC's initialization. It basically creates a main that's empty. They do have a default where they configure and enable your interrupts. That's fine. We are going to go in and we're going to just test out that this works. Okay. So the first thing we're going to do in the main .c file is we're going to include the header file so that we can call the active routines. Okay. And then what we're going to do is we're going to send out some text. Now, the way you do debug output is you specify a virtual channel. So you can have channels 0 through 63. In this case, we're just going to use channel 0. And we're going to output the text, hello. Okay. And this is in a while 1, so we're just going to put CY delay. And let's just say we're going to output that hello every 10 milliseconds. So we're going to compile this. Okay, we're going to burn it into the device. The processor is now running this firmware, and we are going to go to our Active Pro applications. This is the default configuration for the Active Pro application. In order to capture the data that we just created coming out of the microprocessor, you simply press capture. You can see right now that it will capture the channels that are enabled. We have all 8 digital I/O pins. We also have 3 of the analog channels coming in. And you can see up here streaming in is the debug data wiggles that we have created from our microprocessor. So in order to get those displayed not as just logic analyzer channels, but instead the debug data, we're going to simply go and toggle the bus decoder from off to active debugger 2-wire. We change it to active debugger 2-wire for repress capture, and now you will see as well a section called My Active, which is now printing out the channel 0 data that we are printing from main. And if we go in and we look here, it says hello, and guess what? When we measure it, it's 10 milliseconds apart. Now that you've confirmed that you have your active debug output routines functioning correctly, you can now go sprinkle those throughout your code anytime that you need to see the data. So we are going to also show you how to do an active value. We're going to send that to channel 1, and we're going to make a value that just increases, and we'll show you how it graphs those. Okay, we've included a value variable. We're going to spit that value out, and we'll do it at the same 10 milliseconds. So compile it, run it, program it. Go back to your Active Pro application and click Capture. You now see that we have 2 channels. We have the first channel that was existing before. Now we have added a new channel 1. And you can see that as the firmware runs, it is showing the actual value of that particular variable as it runs. So this gets you all of the data from inside the processor out to the Active Pro, and it's as simple as that. Now that the data is coming from the firmware successfully, you do not need the actual digital 0 and digital 1 waveforms anymore. This takes some bandwidth to send these wiggles across the wire. So what we're going to do instead, we're just going to get rid of them. We don't actually need to see those. We don't need to capture those. The pod itself, the Active Pro, will receive these debug messages by itself, decode those, and only send this data. So we are going to recapture with just that, and you'll see it clears up the screen a little bit, and out comes a very efficient, effective debugging tool for both textual and value information. It shows exactly when the text and values are changing and lets you debug firmware much quicker.